Okay, so we're on to the hyperbola. 6.4, 1 to 27. We're down to our last two sections. And we still have all of this week and Monday, Tuesday, Wednesday of next week. Okay. Again, the hope for you is that you start reviewing for the final exam too, because the final exam comes real quick after our last test Thursday. And so your quote-unquote homework for Friday the 11th would be ask questions about any previous exam, if you have any. Okay. And our final exam is the very first day of final exams, Monday the 14th, 8:10 to 10:40. Again, please note the starting time, 8:10 to 10:40. Okay, so not our regular starting time of 9 o'clock. It's going to be 8:10, 10:40, 2.5 hours for the final exam. Okay. And to prepare for the final, look over the old exams and have all your cheat sheets, your previous cheat sheets, just put them all together. Pretty soon I'll have a schedule if you want to catch me during finals week. I do have limited office hours. I know it's kind of weird because you've already finished the final exam. There's not much reason for you to come to my office hours, but I'm legally supposed to tell you. So sometime during Canvas announcements, maybe this week, maybe even today, I'll post my office hours, quote unquote, for final exams week. Although in our case, it doesn't make a whole lot of sense since you would have already finished the final exams by the time it's office hours. But anyway, that's that. Okay, so we're going to do the hyperbola. I'll do about 6 problems. Once that's done, I'll let you ask questions, and then that's it. Okay, so for the hyperbola, so a quick reminder of where we were. So hyperbola 6.4, page 335. We have 2 kinds of hyperbolas. The one that's going to go either left or right. This is on page 337. How can you tell? It's x squared over a squared minus y squared over b squared equals 1. Okay. You have 2 vertices, just like the ellipse. You have 2 foci, just like the ellipse. Only this time the C is going to be bigger than the A. Okay. And again, notice the concept that the focus is always on the inside of the curve. That was true for the parabola. That's true for the ellipse. That's true for the hyperbola. Okay. The hyperbola that goes up and down has y squared first as positive. Y squared over a squared minus x squared over b squared equals 1. So here are the 2 vertices. Okay, these 2 other endpoints aren't called anything. Okay, here are the 2 foci. Okay, so quite often for these kind of problems, you'll be asked to identify the foci, the vertices, and also the asymptotes. You're going to be asked to draw asymptotes also. Okay, so I'll show you what we're going to be drawing, as I mentioned before. Right, so if x squared is positive and y squared is negative, okay, so again, big difference between hyperbola and ellipse. The hyperbola has a minus sign. If x squared is positive and y squared is negative, you've got a left and right branch. Okay, and this blue stuff, that's considered the hyperbola. It's all one hyperbola. So we don't call it 2 hyperbolas. It's only one hyperbola that has 2 pieces. Okay, you will draw me this box. Okay, you will draw me the asymptotes, but technically those aren't part of the hyperbola. They're just to guide you. It tells you how steep the hyperbola goes. Okay, so A, those are the vertices. Okay, you'll be drawing the foci for me also. They'll be like over here and over here. Okay, and if y squared comes first, y squared over a squared minus x squared over b squared equals 1. A hyperbola looks like this. It goes up and down. 0a, 0, negative a. These are the 2 vertices. These don't call them anything. And here are the asymptotes. Okay, how do you come up with the equation of the asymptotes? Just rise over run. I don't think it's worth writing it down. I don't think it's worth memorizing. Okay, just use your knowledge of slope, rise over the run. Okay, if you do a little bit of algebra here, this turns out to be a squared plus b squared equals c squared, which I think is the better way to present this. And I'll be showing it to you in that fashion. So if you want to write that down right now, you can. A squared plus b squared equals c squared for the hyperbola. Okay, and I'll show you in my work also. A squared plus b squared equals c squared. And that's what you actually remember from the Pythagorean theorem, right? All right, so we're going to get started. You will draw stuff that looks like that and like that. Okay, the hyperbola with boxes and asymptotes and so on. This was the bottom of page 341. All right, so here we go. So I'll do about 6 of these today. I'll do maybe 6 more tomorrow, and that'll be it. Okay, Friday's quiz, I'll give you an ellipse and a hyperbola. Okay, since last time you did a parabola, so an ellipse and a hyperbola for this Friday's quiz. Okay, and then all that's left is something called parametric equations. The last topic, section 6.7, something called parametric equations. You don't even have to write that down now if you don't want to. We'll get it in time. 6.7. Okay, so we don't have to do 6.5. We don't have to do 6.6. Okay, so parametric equations, whatever that means. That's on page 360, it looks like. All right, so I'll do some of these. Sketch the hyperbola, showing the vertices, focal points, and asymptotes, and so forth. Okay, so maybe before I even start, okay, let's ask ourselves, is it the left and right type or up and down? So look at number 1. X squared over 4 minus y squared over 9 equals 1. X positive, y negative, that's going to go left and right. That means it's going to go like this. Number 3, on the other hand, y squared over 4 minus x squared over 9 equals 1. Y is positive, x is negative, so that one's going to go up and down. Okay, and then I'll show you an example here. But just pretend it's like that, I guess. It's going to look like that. Okay. And of course, what about these harder ones? Well, for the harder ones, you're going to have to complete the square again, right? So we can't get away from that game of completing the square and see how that works. All right, so here we go. Get started with some of these. So here is number 1. X squared over 4 minus y squared over 9 equals 1. Graph it, give the vertices, give the foci, give the asymptotes. Okay, x is positive, y is negative. So what is this funny thing? I know the hyperbola is going to go this way. Okay, and a quick timeout for number 3, which I also did. Y was positive, x was negative. So I drew myself a tiny little hyperbola that goes up and down. I automatically know it's up and down. Okay, so for the hyperbola, x positive, y negative, left and right. Number 3, y positive, x negative, up and down. Okay, so you can see my final answer in red. This one's up and down. This one is left and right. All right, so square root of 4 is 2, that's my A. Square root of 9 is 3, that's my B. And please notice this time, for the hyperbola, the designation isn't the larger or smaller number in terms of A and B, unlike the ellipse. Okay, so for the ellipse, we were going by A being the larger number. Okay, no, this one, whichever side is positive, okay, that's going to be my A, and that's going to be my B. And this kind of goes along with the theory, well, if you accept the idea that this is positive, this is negative, right? So in some sense, that's a negative. A positive is always bigger than a negative no matter what. So if you think of it that way, positive 2 and a negative for the 3, then, that kind of goes along with that also. All right, for the hyperbola, a squared plus b squared equals c squared. Okay, maybe I'll emphasize this. This is for the hyperbola. Now, that's not the way it was for the ellipse. For the ellipse, it was a squared equals b squared plus c squared. Right? So on your cheat sheet, make sure you put the distinction. It was a squared by itself. A squared equals b squared plus c squared for the ellipse. That's why I told you to put down for the ellipse there. For the hyperbola, it's a squared plus b squared equals c squared. Okay, so a squared is 4, b squared is 9, 4 plus 9 is 13, c squared is 13, so c is the square root of 13. Punch in your calculator, it's about 3.6. All right, so we're ready. Now, left and right, 2 units. So 2 to the right, 2 to the left. So these are the 2 vertices, and I kind of pointed to them here in red. Vertex 1 is negative 2, 0. Vertex 2 is 2, 0. Underneath the y, 9, so I go 3 up and down. So 1, 2, 3 up, 1, 2, 3 down. Okay, which means if this had been an ellipse problem, and by the way, this would be an ellipse problem, I just have to make one tiny change. Can you guess what the change would be to make an ellipse? Just change the minus 2a plus, and then be ellipse. So I would take that point, that point, that point, that point, and just kind of round it. Can you visualize that ellipse if I connect and go like that? But instead it's a hyperbola, so there's much more work. So what you do is take these 4 points, 1, 2, 3, 4. Don't make a diamond. Okay, instead you make a box like so. So from these 4 points you go straight up and down, across, down, and over. Okay, one more time. This point, this point, this point, and this point. The 4 points you were going to use for the ellipse. Okay, don't go straight to it. Don't make a diamond. Just make horizontal and vertical line segments. So go straight up and down, left and right, left and right. You draw yourself a box. And then you connect the diagonals. If you connect the diagonals properly, it should go through the center. And these are going to be my asymptotes. So the graph gets really, really close to the asymptotes, but doesn't quite touch it. All right. Now, I already know it's the left and right type of hyperbola. So I take the 2 vertices in red and just curve it toward the asymptotes, and that's the graph. If this had been an up and down type of hyperbola, which means y squared is first, I would take that point and curve it toward the asymptotes. And I'll show you examples of that also. And finally, I have to put down the foci. Okay, so 3.6 just to tell me where to put it. But again, when you write it for me, write the exact value, which is radical 13(0) and negative radical 13(0). So 3.6, 1, 2, 3, and a little bit more than a half. And to the left, 1, 2, 3, and a little bit more than half. So F1, focus 1, exact value, negative radical 13, comma 0. And focus 2, positive radical 13, comma 0. Okay, the equation of the asymptotes. So I drew the asymptotes. This is, well, rise over run. I run 2 and I rise 3. So y equals 3 halves x. This one you run 2 and you drop 3, so negative 3 halves x. And they're usually negatives of each other. Okay, so here is everything. This is the whole problem worked out. The asymptotes are y equals 3 halves x and y equals negative 3 halves x. Foci, negative radical 13(0). It's about negative 3.60. And positive radical 13(0). And the 2 vertices are negative 2, 0, and 2, 0. And these 2 points, 0, 3, and 0, negative 3, we don't call them anything, so don't worry about it. Okay, so that's our first hyperbola problem. Okay, number 3. Y squared over 4 minus x squared over 9 equals 1. Okay, this one, y is positive, x is negative. That tells me it's going to go up and down. Okay, so A is 2, B is 3. The algebra is exactly the same. C is radical 13. I mean, we just did A squared plus B squared equals C squared, 4 plus 9. Okay, it's the same stuff. In fact, it's pretty much the same graph, except it's going the other direction. All right, so in the y direction, careful, we're writing y first. In the y direction, up and down 2. So up 2, down 2. In the x direction, plus and minus 3. So 1, 2, 3, 1, 2, 3. So here are my 2 vertices. Vertex 1, 0, 2. Vertex 2, 0, negative 2, if you can see that. Foci, 1 focus, 2 foci, 3.6 again. So 1, 2, 3, and a little bit more than half. Focus 1, 0, comma, radical 13. So I needed a 3.6 just to tell me where to put the dot, but you write it as the exact value, 0, comma, radical 13. And focus 2 is 0, comma, negative radical 13. So that's down 1, 2, 3, and a half. Okay, since I already know it's the up and down type of hyperbola, I take these 2 points, the 2 vertices, and just curve them toward the asymptotes. Same thing, take these 4 points, 1, 2, 3, 4, draw myself a box. Okay, so don't make a diamond. Don't go straight there and there and there and there. Okay, it's got to be up and down, left and right, horizontal and vertical. Connect the diagonals. Those diagonals will be my asymptotes. What's the slope? This time it's 1, 2, 3 over and 2 up. So rise of the run is 2/3. So this is y equals 2/3 x, and the one that's going down would be negative 2/3 x. Y equals negative 2/3 x, because that's 3 to the right followed by 2 down. Okay. So there we go. All right, number 5 here, x squared minus y squared equals 1. I don't see anything underneath, so how do I make it look like this? Just divide by 1. So I'm going to write x squared over 1 minus y squared over 1 equals 1. There we go. All right, squared in x, not in y. It's going to be left and right. So that tiny little thing there tells me it's going to be the left and right type of hyperbola. If y comes first, y is positive, x is negative, it's up and down. So that's what I mean by drawing that tiny little hyperbola there. Square root of 1 is 1, square root of 1 is 1. A is 1, B is 1, that's nice. A squared plus B squared equals C squared for the hyperbola. 1 plus 1 is C squared. C squared is 2. C is the square root of 2, about 1.4. All right, so I go 1 to the left, 1 to the right, 1 up, 1 down. So if this had been a plus, you'd actually have a circle, right? You would just round it and make a circle. But instead, take these 4 points and make a box. In this particular case, the box is a square. So 1 over and 1 up. So that's easy. Y equals x, y equals negative x. Those are the equations of the asymptotes, right? All right, I already know it's a left and right type. So these two are going to be my vertices, and it just curve them toward the asymptotes. So there we go. So vertex 1, negative 1, 0. Vertex 2, 1, 0. Foci. So from the center, I have to go 1.4 left and right. So 1.4 roughly. So negative radical 2 comma 0. And radical 2 comma 0. Okay, so that's about 1.4 to the right. That's supposed to be about 1.4 to the left. Okay. Can't really see it that well. Should put it right over here. Here we go. And notice again the concept that the focus is always on the inside of the curve, no matter if you have an ellipse, a parabola, or a hyperbola. Okay, so I'm finished with this problem. Maybe I'll dig a little deeper, so a little time out here. Sidebar. So parabolas look like this, right? Or it might look like that, or it might look like that, or it might look like that. The ellipse is like that, or like that. Okay. And now we know what the hyperbola looks like. Hyperbola is either going to look like that, or it's going to look like that. Okay. For each of these, if you take just a small portion of the curve, I mean, even, right, you can see that in all 4 parabolas, you know that the focus is on the inside. Even for the ellipse, okay, if you only look, let's just say right at that small portion right there, right, you can't really tell if it's a parabola or ellipse or hyperbola. You would still say, okay, the focus is on the inside of the curve. And same thing for the hyperbola. If you only look at, say, one of the branches, right, if you look at just that, or if you look at just that, same thing, the focus is on the inside of the curve, right? Or like this ellipse, if you look only at, say, this piece right here, it kind of looks like all the others. Right, the focus is on the inside of the curve. All right. Okay, now for a harder problem, 13. So I'll do 13 today, and maybe tomorrow I'll do another one, like maybe 11 or something like that. So this big long thing, 9y squared, blah, 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 I have to complete the square. Okay, so I'll show you one of those. I'll do a couple of these, and then that was going to be it for today. Okay, so 13. 9y squared minus 4x squared minus 36y plus 16x minus 16 equals 0. Okay, so just like for the ellipse, move the constant over. So notice I tossed the 16 over. Okay, and temporarily ignore any red or green stuff. Okay, I put the y's together and factor, put the x's together and factor. So look only at these two right now. Put them together. What's a common factor? And don't take out the y, just a number. So I can take out a 9, right? So 9 parentheses y squared minus 4y. So do you agree that this is the same as 9y squared minus 36y, right? If you distribute 9y squared minus 36y. Then look at the x's, these two, factor out negative 4. So to factor out negative 4, that'll be x squared minus 4x. Double check. Negative 4 times x squared, negative 4x squared. Negative 4 times negative 4x, 16x. Now I complete the square. So do the half and square. Half of negative 4, negative 2, squared. Negative 2 squared is 4. So plus 4 here really means plus 36 here in red because it's multiplied by 9. Right, 9 times 4 is 36. So to balance it, add 36 on this side. And similarly on this side, well, you know it's going to be the same thing, right? It's the negative 4 again. Well, we just did it. Right, half of negative 4 is negative 2. Square root is 4. So plus 4, but this plus 4 is really minus 16 in green. Right, because negative 4 times 4 is negative 16 minus 16. Okay. So if you do it properly, this is a perfect square. This is a perfect square. The right-hand side is 36, right? The 16s cancel out. So 36. 9 parentheses y minus 2 squared minus 4 parentheses x minus 2 squared. So now, looks like that. The right-hand side is supposed to be 1. Just divide by 36. So divide this, 9 over 36 gives me a 4 in the bottom. So y minus 2 squared over 4 minus 4 over 36 leaves me with a 9 in the bottom. X minus 2 over 9 equals 1. Okay, so I finally got it to be the way that I wanted it to be. All right, so this is a translated conic section. Okay, so what's a conic section? Parabolas, ellipses, hyperbolas. C-O-N-I-C, conic section. It was a slice off of a cone, we said. So the center is 2, 2, right? Instead of x squared and y squared, it's parentheses x minus 2. That's a shift of 2 to the right. And replacing y with y minus 2 is 2 up. So the center is going to be 2, 2. And let's see, y comes first. Y is positive, x is negative. So it's going to be the up and down kind of hyperbola. All right, they seem to have the same numbers over and over. A is 2, B is 3, C is radical 13. The author, I guess, seems to like that combination. Okay, so we already did this before. All right, so here we go. So the center is 2, 2. Here it is. So left and right, underneath the x, is 3. 1, 2, 3, 1, 2, 3. Up and down is 2. 1, 2, 1, 2. So here are the vertices. This is now vertex 1 is 2, 4. Vertex 2 is 2, 0. And I didn't even label these points because they're not as important. Where are the foci? Well, I go here and I go up radical 13, and I go down radical 13. How do I write it as an exact value? 2, 2 plus radical 13. That's the best you can do for F1. And F2, 2, 2 minus radical 13, which we know is about 3.6. So from here I went 1, 2, 3, and a little bit more than a half. And I go down 1, 2, 3, and a little bit more than half. But you write it as exact values. So how do you take 2 and add radical 13? Just write 2 plus radical 13. And likewise, that's 2 minus radical 13. Those are 2 foci. Okay, I know it's the up and down type of hyperbola. So I take these 2 vertices in red, curve them toward the asymptotes. And how do I write the equation of the asymptotes? Point slope form. Okay? They both have the same point, 2, 2. Okay? So I'm going to use my y minus y1 equals m times x minus x1. All right, I'll put that down here. Y minus y1 equals m times x minus x1. This is called the point slope form, right? Point slope form. You want to get comfortable with that, especially in Calc 1. When you take Calc 1, you'll be doing a lot of point slope form. All right, so the point ordered pair is 2, 2. Now, what's the slope? Over 3 and up 2. So this is 2/3, and the other one would just be negative 2/3. So here we go. Y minus y1 equals m, 2/3, x minus x1. Y minus 2 equals 2/3, x minus 2. And this one's exactly the same, except the slope isn't 2/3, it's negative 2/3. So notice it's exactly the same thing, except I put a minus in front of the negative 2/3, right? So y minus y1, y minus 2 equals m, negative 2/3, x minus 2. And just stop there. Okay, that's good enough. So that's the equation of that asymptote, and the equation of that asymptote is that. Curves up. Here are the 2 foci. Here are the 2 vertices. And my thing wants to change the yellow every now and then, but there it goes. Okay. All right, so that was definitely a little harder. I'll show you another one of that type tomorrow, not to worry. Okay, then I was going to show you a couple of problems at the end, like 15 and 17. Find an equation of a hyperbola that satisfies the stated conditions. Okay, so give an equation of a hyperbola that does these. So foci and vertices are blah, 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 or whatever. Okay, so I'll do 15 and 17, then I'll be done. Okay, foci are plus or minus 5, 0. Vertices plus or minus 3, 0. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Vertices 1, 2, 3, 1, 2, 3. Aha. That means I know it has to go this way. If it goes this way, that means x is positive, y is negative. And it's centered at the origin because halfway between the vertices is the center, or halfway between the foci. But halfway is going to be 0, 0, right? So I don't have to subtract or add anything. It's going to be x squared over something minus y squared over something. Okay. All right, so the C is 5, A is 3. That automatically means B is 4. Yes, this is a 3, 4, 5, since A squared plus B squared equals C squared. This does fit the 3, 4, 5 pattern, right? If that's a 5, that's a 3. This has to be 4. Okay. So if you memorize 3, 4, 5, you can go straight to it. But if you don't, you can just go like what? This would be A squared is 3 squared, which is 9, plus B squared equals C squared is 25, right? Subtract 9, B squared equals 16, so B is equal to 4, right? So that's a slower way to do that. Okay, so it's going this direction. So x comes first. How much do I go left and right? 3. That means it's x squared over 9. How much do I go up and down? 4. That means it's y squared over 16 equals 1. So that's the equation. Here's the graph. Okay, so we got the vertices. Here are the foci. Okay, what are the asymptotes? I know it doesn't ask for it, but I'll just go ahead and finish it. So 1, 2, 3 to the right, 1, 2, 3, 4 up. So rise of the run is 4/3. So y equals 4/3 x, and the other one is y equals negative 4/3 x, because that would be 3 to the right and 4 down. So the asymptotes are y equals 4/3 x and y equals negative 4/3 x. Okay. I won't give as much detail for 17. Okay. So I'll be done with 17 in a couple of moments, folks, and then I'll let you ask questions. And if not, we're done. I'll do more tomorrow. Okay, 17. Foci 0 plus or minus 5. Vertices 0 plus or minus 4. Okay, so tomorrow, yeah, I know I skipped a lot of these problems, but I'll go back and do some of these and then do more rest tomorrow. Okay, 0 plus or minus 5. All right, so that means I know it's going this way. Vertices are 0 plus or minus 4. Okay. Notice I didn't bother graphing the entire hyperbola this time. It didn't ask for it. It only asked for the equation. So I'm just giving a minimalistic effort on this. So since I know the vertices are like that, it's going to go like so, right? So if it goes like this, that means y comes first. So y squared over minus x squared over equals 1. Okay, so I know C is 5. That's the distance from the center to either focus. I know A is 4, distance from the center to either vertex. And again, that fits the mode of 3, 4, 5. Okay, 3, 4, 5. It's the same algebra as this pretty much. Okay, so y squared over A squared, 16. Minus x squared over b squared, 9, equals 1. So there we are. Okay, so it definitely works. Right, and yeah, the problem's finished. Quick side note, the vertices are on the graph. The foci are not on the graph. Okay? So 0 and plus or minus 4 should make this a true statement. Okay, notice what happens if I plug in 0 right here. What happens when I plug in 0? That's all 0. So forget about it. And if I plug in either 4 or negative 4, what's either 4 or negative 4 squared? 16. And 16 over 16 is equal to 1. Okay, so since 0 plus or minus 4, they are on the graph, they should satisfy this equation. But 0 plus or minus 5 would not work. Right? If you put a 0 here, again, that wipes this out. But you can tell 5 and negative 5 aren't going to work, because when you score it 25 over 16, clearly 25 over 16 is not equal to 1. Okay, and likewise, if we tried to pick these 2 points over here, they wouldn't work either. In fact, we can figure that out. That would be what, 3, 0, and negative 3, 0. So put a 0 here and a 3 here, it wouldn't work. You would get negative 1 equals 1, and that's not a true statement, of course. Okay. All right, I'm done, folks. So let me check the chat. And I see nothing in the chat. Okay, so you can ask me a question now. Either put it in the chat or unmute yourselves. Otherwise, we're done, folks. So let me check to see if I can see that. So any questions about anything, please? All right, hearing nothing, then we're done. Okay, so tomorrow I'll do some more of the hyperbola. Friday's quiz will be on the ellipse and the hyperbola, and then I'll get started on the last section. All right, that's it for today, folks. So everybody have a good day. Okay, bye. See you tomorrow.